subscript. Oh, nice. Perfect. Okay, so welcome today to the presentation. And my name is Wiki, as usual. And today's topic will be about hacking the Rubick. So we today we learn how to make GraphQL resolvers in the subscript indexer. And just for a short recap, why do we need indexers? It's like we don't want to sacrifice the user experience. So most of the time, reading data from the blockchain takes like a lot of time. So basically, the user's devices has to connect to the WebSocket on the blockchain's RPC node, and then using the WebSocket, it needs to read the data, and it takes like a lot of time. Then it's the indexers are really good for analytics, so making data views such as like Spotlight or Series Insight in the Codadot. It's like super useful to do that via indexer. Otherwise, we need to like take a lot of data from the blockchain, which we don't need. And also, you basically can't process remark because remark is currently this like the string in the blockchain. So without indexer, you can consolidate it or even process it. And also, like having the indexer, it provides you the simple graphical interface. So instead of having like a classic REST API, GraphQL offers you to just take the data you need without exposing like a lot of API or useless like queries. And like how does the indexer work? We have basically two types of data in each block, and it's events and extrinsics. First, extrinsics are the call or the transaction that user makes to the chain. So in case of remark, it's like system.remark and takes the argument of the string you want to store in the chain. And then you have events, which are the interactions that are emitted by the chain. So for example, when you transfer the tokens, the event emitted is called the balances the transfer. So it tells basically the users or the block apps that there is some that event happened. And the rule of thumb, basically what we got from the subscript team, it's more effective to process events because there you have a lot of special calls in Substrate, which are pretty tricky to basically index. So it's better to process the events. And how does the generally the processing work? So for each block, we extract we extract all the requested extrinsics or events. So for example, in case of Rubick, it's the system.remark and utility.batch. So when you have like more transaction, you need to check if the utility.batch contains some system remark. And then for each event slash extrinsics called a predefined handler. So we have the handler like map system remark or something like that. And then the handler should basically transform the data to match the schema, the GraphQL one we defined. And then at the end, it saves the data into the Postgres database. And how does our schema look like? We have basically three type of entities in Rubick. First, the collection, which holds the list of the NFTs. So it holds a various properties such as ID, symbol, who issued the collection, then how many NFTs can you store in the collection, and then we have the NFTs and events, and also we store the data like metadata or the block number. The same is also possible to apply for the NFT entity, which basically needs to have the collection entity here on the fourth line, and also it has ID, the metadata, and also the price, like how much user ask for the NFTs. And then we have like if it's burned or not, also block number, and the list of events which happened within the NFT. So for example, when you transfer the token, or you burn it, or list it, or actually create it. And yeah, so the third major entity is the event. So it tells us like also ID, block number when it happened, timestamp, which is the date of the block number, caller, like who made the event, then the current owner, which says like who was the owner at the time when the event was made, and the interaction, which tells us if it was created, listed, or even bought. And then we have meta, which represents the metadata for the event. So it could be the number, like how much, what was the price of the listing, or who was the recipient of, for example, the NFT. And then we have the NFT itself. So let's try and play. Let's query some data. So using Rubick, I can share the link to the subscript playground. And we want to fetch like the first 10 NFTs that have been recently listed. And for the NFT, for the event, I want the meta and the timestamp. And for the NFT, I want the ID and name. I share the link to the playground in the Discord. It should be in the dev coordination channel, and I can give you a couple of minutes. Okay, so hope you have your query ready. And as the example task and how would I write it, I would just make a query called the last NFT list by event, which takes like two parameters, which is the limit, it's a type of integer, and the event, it's a type of interaction. Both of them are required, and we query events with the limit of like let's say 10, where the interaction is equal to the event I want, and the NFT should be equal to false because we don't want to show like the burned NFTs. And as I said previously, from the events we want the meta and the timestamp, and from the NFT I want the ID and name. And yeah, we passed this one. And let's go to the resolvers. So what are the resolvers and why we need them? In general, the resolvers are the functions that expose the certain data to the GraphQL schema, and we use that because we don't want to kill the user's device. So parsing and processing on the front end or on the like client side is making the user device slow, and you don't want it. Well, you don't want it. It happens with us when we were making the first version of the Series Insight. or the spotlight, we took a lot of data from the GraphQL, then parsed it on the front end, and it took like a minute or so to actually process the whole stuff. Then some of the queries are impossible to write. So you can basically write an aggregation queries in GraphQL, or you have to use it on front end. So it's not a good approach. And one of the really nice things is the flexibility of the resolver. So we can write the queries that will return on the data we need. So instead of exposing the whole schema from the database, we just expose what we need. And the best thing is like there is no need for re-indexing. So when you are extending the schema, you have to basically re-index the whole chain. But because the resolvers are the server's extension, you just need to like test it properly if it works, and if it works, just upload it to your server, and it's super easy and straightforward. So what's the current structure on Rubick and where to like put the resolvers? So first we have the mappings folder, which contains the indexer logic. Then we have the model with where we have the generated types by the subscript. So even if it's from the schema or from the chain itself, because this subscript has the chain generated types, which is like super useful, and you don't need to parse the calls from by yourself. Then we have the types, so we define our own TypeScript types. And the last folder is the server extension. So it's the folder where we store our resolvers. And it has three subfolders. First of them is model. So we define inside it how the data will look like in the GraphQL. Then we have the query, which is like the logic how to fetch the data from the database. It's usually written in the raw SQL. And then the resolver subfolder. So there are the functions that will be called when the query is executed. And let's go with the first task. It's issue number 69. And our task is to write a query in SQL that return the number of NFTs that are listed. And there should be just one parameter. It's the collection ID, and it should just return the total count of NFTs. So let's go for it. Oh, Raj is here. And let's look at the solution and how I would write it. This is like the SQL. It's firstly hard to read, but once you play with the queries, it becomes like super simple and easy to use. So first we need to use the keyword select. Then there is a built-in function called count. The asterisk means that we want to count like everything. And then from the table called NFT entity, which is the same like the GraphQL schema, it's mapped one by one. So the NFT entity has the same properties as the NFT entity in our schema. And then we just write the where, which is like the basically conditional clausule. And we say that the collection ID should be equal to $1, which is the variable. And then we also write the end, and the price should be more than 0. So it's really easy and to write, but yeah, you have to play with that. The second task is the issue 29, and we'll code it together. And this task is about write a query in SQL that returns the basic information about the NFT and events. It's issue 29, and the parameter should be the interaction type. So it should be list, buy, send, or consume. And the query should return the meta, timestamp, NFT ID, NFT name, metadata image, and from event we should have a color and the NFT issuer per each event or NFT. And it's a bit harder, so we'll go through that. So we also have the select, and we are selecting the e.meta, the timestamp as date. This means instead of returning it as a timestamp, I want that this variable should be called the date. When I write here something else, it would show in the query as like something else. Then I'm returning the NE. It's a alias for NFT entity dot ID dot NE dot name. Then ME, which is like the alias for metadata entity dot image. Then also NE, the issuer, and e dot color. And I get where do I define these aliases is under each call. So I'm selecting this from event E. So when I would skip the E, it would show me that it would tell me that a lot of these calls are ambiguous. So most of the tables have, for example, the name meta inside of them. So I have to be strict, like which data I want. For example, the NFT entity and the event, both of them has the column named current owner. So the query will tell me like which current owner you really want. So when I define the e that current owner, it knows that yeah, I want the current owner from the event. And then what I'm doing is doing a left join, which means that I just care about these events, and for each event, join me all the NFT entities that share the NFT entity ID and event.nft ID. So I'm basically joining them together. And the left join is telling us I just care about the event, so you don't need to match them all. And I'm also doing it the same for the metadata entity. So I just still care only on about these events. So there's also the left join. And I'm joining it on also like the foreign key. Foreign key means that it is a reference from the one table to another. So this e.nft ID is a foreign key, and this ne.id means it's primary key. So you match them, and it's the same on the another line. So we are basically joining the primary key from the metadata entity on the NFT entity meta ID. So when you check the schema, it looks literally the same. And we also are doing the where clausal, and we just want, for example, here the interaction should be equal to the list. It's a string, so that's why I need the single quote. And then I want to order them by the timestamp and descending. So it means from the newest to the oldest ones. And then I limit the query to 10 because I don't want to take all of the results at once. The best thing is to use the limit and then offset. So we are basically doing the pagination, and it's the best way to try the SQL queries. And now you are thinking like, okay, we have the SQL query written for the database, but how can I make the resolver for the Rubick? And it's exact time to make a resolver. So I will take the query from this task and I'll implement it into the Rubick. So basically we need to edit like 3 files. All of them are stored into the Rubick slash server extension. And we first need to edit the query slash event dot TypeScript. Then I need to edit the model, so event dot model dot ts, and then resolvers slash nft events dot ts. And how did I make this these names or these files that I should use, I'm gonna, if you look at the query, I'm selecting from the event. So that's why I want to like edit the query event, and then I want to edit the model, the event.model.ts, and the name of the resolver is based on the like what's inside. So sorry. And yeah, let's edit the first file. So it's the queried event.ts. And basically what we are doing here, I just copied the whole SQL query from the slides before, and I assigned it into the constant called NFT event list, because it's our event related to the event and it's the list. It should return the array. And then I'm exporting it so we can reuse it in other files. So basically I use backticks and then paste the whole SQL query into this. And also, if you can check, I replaced the hard-coded list to the $1, which tells us that the parameter on the as in the first one in the array of arguments, when I will be executing the query, will be the variable that represents the event, and then I have here the $2, which is basically saying the same. Like the second element in the array will be representing a number that should go to the limit. And then we need to define the model, like how the how the model will look like, or the data will look like. And that's where I create the model slash event.model.ts. And always it needs to have the annotation of the object type. It's from the type ORM. So you basically import it. And then I need to create the class. Also, I need to export it so we can reuse it in other files. And then I name it like a token event entity because it's related to the token and the event. And I usually use the prefix entity, so I know it's like sort of, let's say, object. And then I need to define like all the respected fields for all these types. So for example, for the meta, timestamp, ID, name, image, issuer, and caller. So I do the same. I start with also the annotation, which tell us like it returns us the string, and the nullable false means that we should always have the value. If the query doesn't return the value, the whole like query will crash basically. So we need to test like the whole what query and the resolver properly. So we have to be sure that yeah, this always returns the value. So I defined the ID as a nullable false, so I'm sure that I will have always ID. Then I have the next field, which also returns string, but in this case it's nullable true, and it's called the name. So I don't need to have, for example, name in the NFT. I basically can create the NFT with the empty string as a name. It's up to the user. Then I have the date, which I know it's also which returns the date, and it's not a false. That means I will always have date. Then I have the next field called the meta, which is type of string. It's nullable true, and I can set the default value to the empty string. So instead of having the null, I will have empty string, and it's easier to parse on the front end than having actually the null. Then I have the same for the image, and for the issue and color, I have the nullable false, which means that it's required. And if one of them would be null, the query also will fail. And the third, we just have to finish the resolver. And also in the like resolver slash NFT event .ts, I'll create the basically the file, and it starts with the resolver. It's from the type ORM, and it exports the class, and I call it like NFT event resolver, so I know it's resolver when I would see it. And this is like the boilerplate. It needs to have the constructor with a private field called transaction, and it should return the promise of entity manager. You just need it. It's like one of the requirements. And then we'll define the query with the annotation of called query, and it tells us it will return the token event entity which we defined in the file before, and this means it's an array like the brackets. So it returns the array of token event entity, and the name of the query is called the NFT event list by type. So if you played with the Rubick before, you have the NFTs, you have the NFT by ID, and so on and so on. And this will show you in the graphical schema that we will have the NFT event list by type. And it takes the two arguments as we talked before. The first one is type, it's nullable false. So we always need like this, argument, and then we have a limit, which is nullable true. So we don't need to pass the limit basically, and it's type of number. And how to define these arguments? It just also with the annotation arg. Then for first parameter is like name of the argument, and then the optional stuff. And as we can see, it returns the promise of token event entity array. And how to make the resolver is basically super simple. I wrote the utility called the make query, and you just have to like import this make query function, and the first argument is like the this.tx, which is from the constructor. Then it needs the event entity, and it's because when you know from the query we are selecting something from event, and the second argument it's tell us like which object do we want to query. If we start like select asterisk from NFT entity instead of event entity, we would have the NFT entity. If you would start with collection, in the collection entity. It's for the type ORM, and how it works. It needs the type. Then, as the third argument, it takes the query we imported, like the string one, and then it takes the argument, and it needs first the type is the $1, and then the limit it was the $2, and then we just await for it and return the result. And the last thing we need for the resolver to be so we can play with it, we need to actually the registered resolver. So in resolvers slash index.ts, we import like our NFT event resolver, and at the end of the file we export it. And how does it look like? I'll go to my localhost. Oh, I'm connected. Oh, give me a sec. Okay. So on the branch where it is implemented. So it's already on the PR. So if you would like to check by yourself, it's in the repo of Rubick. So github.com/code.slash/Rubick, and it's on the PR. And if you look at the Explorer, you're all already played with, for example, connection entities or connection entity by ID. And when you look and when you go through all of them, you see the NFT event list by type. Here's the exact resolver we defined. And if you see, it takes the two arguments we defined. So it was limit and the type. And it exposed all the fields we defined via the event.model.ts. So let's make a call. So I want the type of list and the limit of 10. And from the query, I want the name of the NFT, the image, and for example, the metadata. And when I run it, you see there are like a ton of lists. Or let's make this away. There are like a lot of lists for the NFT with name Jerome, and there is like a metadata. It means like the how much the user listed for the NFT. So you see this is like a huge number, this like less than one, and then also to the big number. I think it's already two kusamas or something like that. And if I change the type from list to, for example, by, it you see it's the different. And for example, when I add the bed type, for example, instead of by as just a boo, it returns me the empty array. So I should be safe. It doesn't fail on the front end. So yes, that's how you can hack your Rubick. And we have like a lot of issues. Yeah, this is the query. So when you go to the branch 29 to event resolver, you can build it, serve it via your GraphQL node, and you can play with it with your query as I showed before. And things to know. Here's the link for the Rubick, and we have like a ton of issues for Codedot in general, and also for the Rubick. So yeah, unleash your creativity and build a resolver for the Rubick. And as I said, it's like you make a PR to Rubick, merge it, or someone from the review guild, and we deployed it almost instantly to the subsquid because they are our current provider. And the super thing about the resolver is that we don't need to reindex the chain, so it will be available in Rubick/006 in like no time. And yeah, the next session will be about index your own data. So we're gonna actually extend the Rubick with the new data from the chain. So we will index our own events and our own extrinsics. So don't forget to join. And yeah, do you have any questions? So if not, thanks for joining us, and see you in the next GraphQL session or the hacking session. Ooh.
Yeah, thank you. This was really helpful.
Thank you.
Thanks for joining.
Bye bye.
Bye.